Hello everyone, welcome to Infinity Maths. Today we are going to learn class 10 maths logarithms. So what is logarithm? So first we have to learn the definition of logarithm. So logarithm is an inverse of exponent. Logarithm is an inverse of exponents. Exponent and logarithm both are inverse to each other. So if a power x is equal to n, if a power x is equal to n, then x is equal to log n. X is equal to log n. Base is a. Here we have base a. X is equal to log n base a. If a power x is equal to n, then x is equal to log n base, where a is not equal to 0. A is not equal to 0 and a is always greater than 0, and also b also always greater than 0. If a power x is equal to b, then x is equal to log b. If a power x is equal to b, then x is equal to log b. Base is a. So this is the definition of logarithms. So see some examples by using definition. So how to convert exponent form to logarithmic form and logarithmic form to exponent form. So see the definition first. A power x is equal to b. If a power x is equal to b, then x is equal to log b base a. The similarly first one 2 power 3. 2 power 3 is equal to 8. Then 2 power 3 is equal to 8. Then by using this definition, 3 is equal to log 8. 3 is equal to log 8. Here we have base is 2. So apply base here. 3 is equal to log 8 base 2. 3 is equal to log 8 base 2. The second one 10 power 2. 10 square is equal to 100. If 10 square is equal to 100, 10 power 2 is equal to 100. 10 power 2 is equal to 100. Then 2 is equal to log of 100. 2 is equal to log 100. Base is 10. Log 100 base is 10. Similarly, Similarly, we have 5 square is equal to 25. Then 2 is equal to log 25 base 5. 2 is equal to log 25 base 5. So this is conversion of exponent form to logarithmic form and logarithmic form to exponent form. The next, what are the major conditions in the definitions? Already I explained as a is always greater than 0 and a is not equal to 0. A is always greater than 0 and a is not equal to 0. B also always greater than 0. A is greater than 0. A is not equal to 0 and B is greater than 0. So a comma b are any two positive integers here. The next thing is properties, basic properties of logarithms. So what are the basic properties of logarithms? Log 1 for any base, log 1 for any base is equal to 0, always 0. Log 1 value always 0 for any base. Next, log a base e. Log a base e is equal to 1. For example, log 2 base 2 is equal to 1. Log 3 base 3 is equal to 1. Log 5 base 5 is equal to 1. As well, like a is not equal to 0. Here condition is a is not equal to 0. Log a base a is equal to always 1. The next thing is log a power x. Log a power x base a. Log a power x base a is equal to x. So this log a power x, log a power x base base a is equal to x. This can be written as x into log a base a. X into log a base a. Log a base a already we know that 1. Then x into 1. X into 1 is equal to x. So log a power x base a is equal to x. Next, a power log b base a is equal to b. Here this a and log base a both will be cancelled. Then the value will be b. A power log b base a is equal to b. So here log b base a is defined only for b is greater than 0, as we learned in the previous session. So b value always greater than 0, a also always greater than 0, and a is not equal to 0. These are the major three conditions for logarithms. Next, what are properties of logarithms? What are laws of logarithms? So we have 5 to 6 rules in logarithms. First one, product rule. What is the product rule? Log m into n. Log m into n is equal to log m plus log n. Log m into n is equal to log m plus log n. Next, quotient rule. Log m by n base a. Log m by n is equal to log m minus log n. Quotient rule is log m by n is equal to log m minus log n. Next, power rule. Log m power p or log a power x. Log a power x is equal to x into log a. X into log a. Here log m power p is equal to p into log m. P into log m. The next rule is change of base rule. Log b base a. Change of base rule is log b base a is equal to log b by log a. Base is c, where c greater than 0 and c is not equal to 1. C always greater than 0 and c not equal to 1. Change of base rule. Log 5 base 2. So this can be written as log 5 by log 2. Log 5 by log 2 base 10 base 10. Log 5 by log 2 base 10 base 10 by using a change of base rule. Next, reciprocal rule. A reciprocal rule is log 1 by m. Log 1 by m is equal to minus log m minus log m. Next, log 1. As we know already, log 1 for any base the value is 0. Log 1 value for any base is 0. So types of logarithms. So how many types of logarithms we have? So in the previous session, as we know, by seeing some logarithms have base 10. Some logarithms there is no base. If the base is 10, then they are called common logarithms. The logarithms with base 10 are called common logarithms. For example, log b base 10 also can be represented as log b. Log b base 10 also represented as log b. Next, natural logarithms are Neperian logarithms. Neperian or natural. Logarithms with base e. Logarithms with base e are called Neperian logarithms or natural logarithms are so here base log b base e is equal to in log b. So where e is equal to 2.71828. E value is equal to 2.71828. Next, logarithm basics as we learned in the previous session. So by using that properties, so how to find it? This one, see, log 1 base 2. Log 1 base 2 always equal to 0, and log 3 base 3 by using log a base a formula. Log a base a is equal to 1. So here log 3 base 3 is equal to 1. Next, to log 125 is equal to 3. How log 125 base 3 is equal to 3? So once listen carefully here. Log this 125 can be written as 5 power 3. Log 125 can be written as 5 into 5 into 5, 5 power 3. Base is 5. So here using power rule, log x power m. Log x power m is equal to m into log x. M into log x. So here 3 into log 5 base 5. 3 into log 5 base 5, where 3 into log 5 base 5, log 5 base 5 value is 1. So 3 into 1. 3 into 1 is 3. So log 125 base 5 is equal to 3. So next one, log 1000 base 10 is equal to 3. So how the log 1000 base 10 is equal to 3? Log the 1000 can be written as 10 power 3, 10 into 10 into 10, 10 power 3, base is 3. So again using the power rule, log a power m, log a power m is equal to m into log a, 3 into log 3 into log 10 base 10, 3 into log 10 base 10, log 10 power 3 base 10. So by using the quotient rule, 3 into log 10 base 10, log x power m is equal to m into log x. Here log 10 power 3 is equal to 3 into log 10 base 10. So as we know already, log 10 base 10 value is 1. Log 10 base 10 value is 1. Log 10 base 10 value is 1. So 3 into 1 is 3. So log 1000 base 10 is equal to 3. If you like this video, like, share and subscribe Infinity Maths.